Hi, this is Nick Earle with the intro to our 50th. Yes, we really have done 50th IoT Leaders podcast. And this time, for this one, we're going to go back to where we started, which is where we started as Eseye as a company. And I am interviewing Ian Marsden, who is our CTO and co-founder of Eseye. He's just coming up to 17 years at the company. And so who better to talk to about what the long-term future of IoT could be in the industry, especially as Ian has a track record of making predictions, turning them into engineering products, implementing them, and being proven to be right. And we talk about that at the beginning of the podcast. This is really a sort of prep podcast for a piece of collateral on our website, which is our IoT predictions report. And it is our number one downloaded piece of collateral off our website. This time we're going to be looking at three questions. One is the future of the MNOs. We use the Mark Twain analogy. Are reports of their death greatly exaggerated, or will they become the leaders in the new EUICC, eSIM, SGP32 world? And if so, what decisions do they have to make and what do they have to do? We have a very good conversation about that. We then go on to look at the other end of the spectrum, in many ways, narrowband. And there's been announcements on narrowband not being supported from a long-term point of view by some operators. And we ask and debate, is there a future for narrowband? And then finally, the topic that's on every podcast, no matter who you listen to, and it's AI, artificial intelligence, and really drill into, so what is the real use case for AI? What's the potential for AI in this world of multi-operator, multi-rat, single SKU connectivity? Where would the value of AI really be going forward? And Ian talks about what he believes will be possible. And again, as I said, as the person who designs and builds our solutions, it's comforting to hear him talk about that. So that's the podcast. And let me hand over straight away to my discussion with Ian Marsden, our CTO and co-founder. Here we go. So Ian, welcome for the second time to the IoT Leaders podcast.
Thank you.
So as you know, this podcast is an internal one. It's within the family, so to speak. It's two people from SI talking to each other. But in this case, the reason is because we do an annual predictions report in the industry. A lot of people take a lot of interest in it from all over the industry. And so this year, I thought I would interview yourself. You have been our visionary for almost 17 years now, since you co-founded the company with Paul. There's been a series of very bold decisions that you've taken to drive the strategy of SI, which in retrospect have been very smart decisions. I'm sure there's been a few which perhaps weren't as smart, but most of them, I think it's fair to say, have worked out. And they included building a federation of the operators to work in an almost airline type star alliance model, embracing multi-IMSI very early on, bringing out a SIM that works along the lines of an eSIM with EUICC before the EUICC was a thing, and then recently embracing the device resident application in the form of our Smart Connect. So the idea of almost the intelligence being within the device as opposed to being within the cloud. And so I can't think of a better person to interview about our predictions for the market going forward. And we do this at the end of each year, and then we find out in a year's time how well we did, or the market tells us, if you like, how well we did. So this year we've got three, and we'll go through them one at a time, just to give everyone a heads up of what the three are. The first one is the MNOs will fight to take back control of IoT, or if I was to paraphrase that, I'd use the Mark Twain quote, which is reports of the death of the MNOs greatly exaggerated. The second one we're going to talk about is what is the future for narrowband IoT specifically, because there was a lot of publicity over it. There was a lot of people asking about it, but there've also been some recent developments that starts to cause a lot of people to question it. I'm going to talk about that. And then the third area that we'll get into is the whole subject of artificial intelligence, which is obviously the subject of pretty much every podcast right now. But specifically, what actually is the likely role of artificial intelligence in relation to IoT? So that's the third one we'll get into. So that's the table laid. Let's start off on the first one. I'm going to ask you, as someone who, as I said at the beginning, has had a vision for almost 17 years now. You built our solution around the operators' needs. But there's a lot of people out there that are saying, well, the operator model is fading, and actually the MVNO model is going to take over. And they quote multiple data points, if you like, to justify that. They talk about the fact that the financial model of the MNOs is really in distress because they sell pure connectivity, but data prices have been declining. I know in the 6 years I've been at Eseye as CEO, data prices have declined by about 10x in that period, which is quite something. You've got to sell a lot more data every year just to stay flat. We know that roaming agreements break all the time, and you can't rely on the roaming agreements. And sometimes you get quotas that get exceeded, or people turn off roaming, so that is tough for the MNOs. And sometimes the big MNOs can really only cover their national market and limited roaming globally that they can rely on for 10 years' time. At the same time, they're investing a lot in building out 5G. So there's a lot of other priorities for them other than IoT. And also they're still using platforms which in many cases have been around for 10 or 15 years. They were platforms that were designed just to take their offerings to market. But if you look at some of the announcements and developments in the interoperability and the standards field, we now have not just the eSIM, but we have EUICC and now coming very fast towards us SGP32. So interoperability between the operators is suddenly being enabled through the standards bodies. And if you take all of these things and you blend them together, the question is, the operators who for 40 plus years have had a model of taking their offering to market are suddenly now looking at very difficult financial situations, declining data, and a demand for multi-operator solutions, which is not what they do, to collaborate with their competitors on a global basis, not just national. So that's the background to all of this. So the question is, what is the future for the operators? And I know you feel very strongly they can fight back. And in fact, they will be the long-term winners, but only if they make certain choices and they make certain moves in the market. So what's your view on all of that? Are reports of their death greatly exaggerated?
As the Mark Twain quote. So yes, I mean, I think, obviously the thing that they have in their arsenal is the fact that they are the operator in a particular geographic region. They have licenses to operate, etc. And therefore, in terms of who can provide that coverage in those locations, it's the operators. So it's kind of in their gift to work out how to sell it. And you alluded on some of the changes that come out in that market, which is arguably them beginning to fight back in some of the roaming restrictions and the access fees, etc., coming out. And these are methods of rebalancing that shift from the roaming to the local. Now, again, you allude to historically, of course, there was more money in that connections, and therefore roaming was a more expensive method of delivering IoT. And as the prices have eroded, the two have become more equitable, and which is why they're having to fight back in that respect. But of course, the control is with the operator. They fundamentally have the ability to set those prices. And if it's a market that they choose that they want to fight in, rather than just being a wholesale provider, then it's for them, definitely for them to choose. One thing I will point out is you might say that the price of data has come down tenfold. on the other side of that, of course, is the amount of data that IoT applications shift has increased. And if you look at applications in general, not just IoT applications, there's a trend there that is likely to come in as well.
Yeah, in fact, just to add data points on that, I often on these podcasts, by the way, I think this is our 50th podcast, so how about that? So we get the founder on for number 50. But I often on these podcasts refer back to my years at Cisco, where we thought for a long time, a similar dynamic occurred in at the IP layer in networking. And then suddenly, voice it was data first, and then it became voice, which used more packets than data. And then the really big kicker was video. And when you start filling up the pipes with video packets, suddenly it's not just the price that's coming down, but the use cases go up. And we see a similar thing in IoT, of course. Now, even basic POS devices that we have a customer doing a POS rollout of a point of sale device that is going to use 500 megabytes a month. That gives you you don't need 500 megabytes a month to check a credit card. So a lot of these devices have video interfaces on them, but still the pressure is relentless on the data price. And we'll get back to this when it comes to narrowband IoT. But it's hard to find those value-based high ARPU use cases for the operators as well, for anybody actually.
But even if you don't just look at the value, you are seeing the value is not just monetary value; it's also value of the data, and therefore I think you get a split slightly in the application space between somebody who's just trying to buy something that's how cheap can I make it, versus somebody who's trying to actually deliver a high value service across the top of it, and therefore there becomes a value judgment in the delivery of the service, not just price.
So what do the operators need to do to get to that high brand of value when it comes to IoT, given the market dynamics that I laid out?
So, I mean, we obviously feel quite strongly about that because we, over the years, very much drove the move to using roaming to provide multi-network access for higher availability, and then driving that to multi-IMSI EUICC to provide multi-profile access, again for increased levels of resilience and accessibility. This is all about how do you provide a higher level of quality and access onto a network, which allows you to provide a better level of service and therefore hit that value end of the spectrum. And as I alluded to earlier, operators need to decide whether that's where they want to play, or whether they want to play at the low end of the market, and that's their choice. But there is clearly a value in certain application spheres, etc., where IoT becomes more critical, more relevant to everyday life, and things that actually we take as important. Then actually that value play does come back in. So to answer your question, operators first need to decide how they want to play, but if they want to chase that, they need to make sure that they're looking at platforms and solutions that can actually meet those customer requirements, and those customer requirements are higher levels of service, higher layers of availability, both in country and internationally.
All the operators, so let's choose it. We're talking about an operator or a group of operators who choose the value, not the volume, because to your point, not everyone will choose a value, but let's say they do. They want to keep their customer relationships. They want to be seen as a value-added provider. They want to do land and expand selling in the future, because IoT has a huge amount of potential beyond connectivity. But you mentioned platforms. They've all got platforms. There are some very large platforms out there. My ex-employer, I think they have about 35 operators using what was called Cisco Jasper. Of course, the Ericsson, what was called Ericsson's DCP, now with Aris. And there's a whole bunch of others. There's a long tail of platforms, including some homemade ones. So they all have a platform. Are those platforms, are they capable of doing agnostic operator global
And so, yeah, I mean, historically, they've not been in that sector because they were built primarily for a single operator to achieve a singular level of connectivity. And so the risk here is that you end up with multiple platforms and making the supplier or the customer have to use multiple platforms. And historically, we used to think of this in the scenario, well, you're trying to deploy in 80 countries, you need to go and talk to 80 operators, you need to go and speak 80 languages, set up 80 contracts, etc. And that's a pain in its own right. But if you then add, and I want in-country roaming, I now need to multiply that by 3. Suddenly this actually gets a really complex task, and therefore you're looking for solutions from the platform layer that can make that task simpler. And what's interesting in a way is that's at odds to just doing orchestration of profiles, because that might make it you can move them between the different things, but that hasn't necessarily solved the actual platform discussion. Now, obviously, you then get some overlay platforms that would sit on top of it and say, okay, I can bring this lot together at a user interface level, but that doesn't necessarily bring it together at a support level. And that was back to alluding are you selling premium and what's the customer actually trying to buy? So we can see a shift in the market, and that shift is moving to worrying about that overall service delivery to customers, especially those high-end customers.
So I mentioned the federation is, we have what we call our AnyNet federation, and there are 16 operators in it currently. For people listening to this podcast that might not know what it is, could you just briefly describe what it is and specifically how it provides an architectural framework to solve that issue that you just talked about?
Yeah, so from the customer's point of view, the problem I outlined earlier, which is customer wants to deploy in multiple territories, multiple countries. They want to see a single SKU that can be deployed all over the world, that meets all of the latency, regulatory support, offering requirements of their application. So that's the sort of remit for us existing in the first place. The question is, how do you do that in the framework of making sure that you can deliver that for longevity, as in applications that are going to be out for 20 odd years? So that's where the federation comes in, because there's the number of partners who are basically signing up to saying, actually, we are delivering, we are happy to enable service on the federation, and we're happy to enable it for other partners to be able to use that. And that becomes the federation that builds out, which is realizing that by themselves, they operate in a market. They might be dominant in their market, but that isn't the whole world. And if you take the reciprocal view and look the other way, it looks different, but equally kind of the same. And that comes back to your airline alliance sort of scenario.
Analogy, yeah. Well, I was going to double click on that because the question was going to be, which is, well, how is that different from a roaming model, which is the majority of ways people try and solve this is via their roaming agreements. But to shine a light on that airline model, from a consumer point of view, the reason that the airline alliance is like Star Alliance, but there's never just one. There's also, for instance, One World in the airline industry. The reason, and others, the reason that they came about was because the customers didn't want the inconvenience of hopping between airlines and having different contracts with different airlines, not being able to share infrastructure like gates, ticketing. They wanted hubbing. They wanted to be able to fly into one airport and have a guaranteed connection, ideally from the same terminal, but at least from the same airport to where they wanted to go to. So they wanted global connectivity from a consumer point of view. And as a result of that, the big airlines went from a proprietary model to an interoperability model by an independent third party, now in this case, Star Alliance, which is in itself a separate company managing this on behalf of the airlines. So it is do you believe fundamentally that a model like that, which we already see emerging, of course, but a model like that is the way in which this problem has to be solved on behalf of, not the airline passenger, but on behalf of the enterprise, to achieve single SKU, that model has to be implemented?
Yes, but I'll go back a little bit because one of those things you said, we've already kind of got this a little bit in roaming. But to try and extend that analogy, of course, in roaming, it's a bit like in roaming, an interoperator agreement will agree a price for connectivity between the two operators. So that's a bit like the two airlines in the alliance agreeing what every single seat will cost for the next year. So there's no flexibility in that model for them to adapt based upon capacity and stuff that's going on in the market and whether more people are buying and more people are selling in different directions. There's no flexibility in the roaming
pricing.
Exactly. Yeah. So where that changes is in from the point of view of the federation, we believe that you have to get this overlay layer, which effectively allows you to look at IoT applications as different types of IoT applications. There's a lot of different types of IoT applications that we already alluded to between low end, high value, but you can do this in every dimension about, are they temporary roamers, are they permanent roamers? And therefore the roaming model as it stands is kind of too blunt an instrument to deal with this. That's why we believe the federation model has to come in. And it's not just that it's a federation, but it's also the models underneath it that allow the operators to play.
Exactly. I was going to say that because it's not just a different way of doing roaming, because the federation does offer the choice of orchestration of both roaming and localization of the connection, which is a very different model and is much better. It's much better for the recipient of the traffic because then they're getting a much higher revenue per device than roaming, which typically runs at about 20% of the revenue per device. So was that always a key design objective for you when you were building this? I mean, I know initially it was seen as just trying to get to multi-IMSI, but then the idea of federated orchestration of both roaming and localization through a central switch and a set of rules. Was that always a key design?
Yeah, I think so. But I think it comes from the premises that, IoT is such a big market, one size does not fit all. And therefore there's always the flexibility. You have to have the flexibility in the solution, no matter how you're looking at it, because you need that flexibility in any system that's going to adapt, especially over a long period of time. It needs to be able to have that flexibility in it.
And a final question before we move on to the second question around narrowband. If I like the analogy you use of roaming is like pricing every seat 12 months in advance, which doesn't allow you to flex up and down for demand. I think that's a good analogy. But does that then mean that the operators, do you think they will replace the current platforms, or will this become an overlay with this capability as a native cloud SaaS pay-as-you-go capability become a sort of clip-on? Does it like a platform of platforms that sits on top of their existing platforms? Is there room for both?
Well, I suppose we're talking about telecoms. The world doesn't move very fast in telecoms. So if we're doing predictions for next year, the answer is no, there is definitely room.
Let's wave the magic wand and make 1 year 10 years.
Yeah. I think those platforms will probably get replaced and the platforms will become more flexible because there's having multiple platforms to meet multiple requirements. Operators are really good at doing that, but that doesn't make it the right answer. And often they do try and consolidate their platforms. And if you're looking at a 10-year horizon, then I think consolidation between IoT platforms that are solving the in-country roaming, international elements, I think naturally they will evolve together.
Okay, so Mark Twain's got a future, they're alive. However, they do have to make that choice that you referred to at the beginning, which is, do they want to play in the value space? Because they don't necessarily have to. And I think that probably gives us a very nice segue into the second subject, which always has got a little bit of a Mark Twain spin to it, which is there a future for narrowband? Now, we both know that narrowband has a huge amount of advantages. technically. Price, battery management, a whole series of advantages. And there was a massive amount of demand and interest in it over the last few years. But also over the last few years, we've started to see a few announcements from some big players who've said, no, we'll be ceasing support for narrowband. And so my question then is, and there was one publicly, very recently, AT&T, obviously a very big provider, said there wouldn't be a long-term future of narrowband from AT&T. So when AT&T make an announcement like that, it really is significant. So the question is there a future for narrowband? Will narrowband still be a thing, or is in your view the writing on the wall? And if the writing's on the wall, is that a technical issue, or is it primarily a commercial issue?
So I think, I mean, again, back to the telecoms timescales, I think in the end, the writing is probably on the wall in the long run. But equally, there are deployments that long run. My 10-year magic wand rather than my 5-year.
Yeah.
But there are clearly some areas of the world where large deployments exist, and therefore those deployments have got to critical mass, and therefore that is something that isn't going to go away, and it's fine. So this kind of splits back into the previous comment about, are you talking about global deployments, or are you talking about local deployments? Because if you're only worrying about local deployments, then you can make the decision in the context of local, and that might be a different thing. But also you alluded to some announcements for where they were notifications about end of life in, but also we know a lot of operators that were thinking about launching and ultimately have never got there and are unlikely to ever get there. And a lot of this is not necessarily that it's the wrong technology. There's lots of examples in history about good technology is not necessarily making the cut. The challenge here, historically for many years, IoT of course has been subsidized indirectly by the operators because they've already had the infrastructure, and therefore adding IoT on top of it is a marginal cost. Now, narrowband, one of the challenges on narrowband always was that actually it's very obvious the cost, and it's very obvious who it needs to be applied to, and therefore that need to very quickly get to critical mass to be able to justify the investment or the continued investment in running it is one of the challenges you get when you can't do a cross subsidy.
And that helps explain why there is a part of the world where it's still alive and well and thriving, which is China, of course, where it is a very high percentage of all connectivity in China. But to that last point that you just made, you have a very large operator like China Telecom who has got critical mass, and so they actually have got over that hump. And there's a lot of money being put behind it, and a huge amount of devices using it. So it's got to that point where I'm assuming it's making money for them. They're really pushing it. But it's difficult when you then follow the long tail of operators down to the rest of the operators, where you tend to have 3 or 4 operators per country, and 190 countries. So it's sort of an economic. I said, is it technical or is it commercial? You could argue it's actually to do with the fundamental economics of how to make money from narrowband.
Yeah, and I think so. And then the global element also didn't help. So I think that's just if you look at it within the regional. But if you look at the global element, the problem, and historically, why 2G still is even talked about in this industry is because of the need. The globe is a big place and lots of operators, and they all have different networks at different stages of evolution. And therefore, the need for backwards compatibility is one of those things, if you're looking for global deployments, is really important. And the problem with narrowband, again, needing different modems, and you look at the modems, some of them had backwards compatibility options. But if the only reason you were designing it is because you needed the power saving that narrowband would give you, you then couldn't make use of the fallback options. It all adds to the complexity and the problem that means that potentially the business case for the customer doesn't stack up, let alone for the operator.
So if I was a customer, what advice would you give me if I said, I was about to bet bet the farm on narrowband IoT. Actually, a lot of agriculture use cases were narrowband IoT. I was going to bet the farm on it. What are my alternatives if I want to protect myself going forward?
Well, I would first start with always the question about where you're going to deploy it. But I mean, it's interesting because we obviously help customers with Smart Connect and etc. build a number of different products in there, and often you have to look at not the technology could be an option to help you, but you have to look at what the alternatives are. So as in, if narrowband is not available, what's it going to do? And that's about your power profile, your power budget. Are you making use of alternative energy sources? And you also have to look at sometimes customers look at the modems and go, oh, that modem's cheap. But you have to factor in, is it cheap because it delivers a good service over the lifetime of the product? And if that product's a 20-year lifetime, actually that's much more significant than necessarily saving a small amount in the modem. So to a certain extent, you have to look at the whole business opportunity holistically, and my viewpoint on that. And again, we have customers that we help design their products, and sometimes you do end up with almost a counterintuitive decision because you have a truly global product that might not be sending a lot of data, but the category of modem ends up going because you want long life, maximum coverage in all over the world, and actually that might drive a different decision. So there isn't one answer, because if you're building a small, low cost, low lifetime product, you quite possibly would make a completely different decision to something that's going to be out there for 20 years.
Okay. One other question. Some people would say, well, with satellite coming, one of the issues in narrowband, as you pointed out, is just the investment versus the return. And but with satellite, of course, you get truly global coverage, oceans, land, agriculture. It doesn't matter, farms, remote farms. It's no longer the towers are where the people are. The people tend to be where around the cities, but a lot of the use cases are everywhere else. But therefore, satellites over the long term will solve this. But does it really solve it? Because if the underlying operators aren't supporting it because they can't make money, does the satellite solve the narrowband?
Satellite solves a different problem, but it doesn't actually solve the physics engineering part of the problem, because of the power consumption. But then it kind of comes down to what's the problem you're trying to solve, because satellite for coverage in emergency situations or very high value situations is great.
Yeah.
So and of course there's what's interesting equally is on a lot of applications, the value of the application actually changes dynamically, as in something that's monitoring something that's in a normal condition is very low value data.
Yeah.
If it becomes I don't know, something's been stolen or something and you need to track it, then that becomes very high value data. So that's not only in terms of power consumption, but that's in terms of actually value of the information that's being delivered.
Yeah.
And therefore you can, so I think multi-RAT in that element, as in whether it's satellite or these RAT types, is all part of that mix, but it's down to the application and the business case.
Okay. Application. Okay, that's a good prompt to move to question number 3. I can't think of a way of bringing Mark Twain into this one, but who knows? Maybe Mark Twain was an expert on artificial intelligence without knowing it. AI is everywhere. We all know that. It used to be cloud washing, and it's very definitely now AI washing. Everyone now has an AI strategy, magically. But in IoT, I don't believe that there's really been a clear definition of what role AI will play. I know you've thought a lot about this and have a view. And from what I know of that, it's not a view that I've seen elsewhere. So I think it's worth exploring. So basically, this is an open question, which is, what role do you believe AI could play in the future? And don't worry about the 1-year time horizon. Let's give you But it's not 10 years. Let's give you 2 or 3 years. What role could AI play? Where's the value in IoT for an AI use case? What's your view on this?
Well, so I think where we sit is a slightly different question because in a way IoT is a number of players coming together to deliver an overall solution. If you look at any of our applications, there's always multiple stakeholders, and in fact, that's one of the reasons that IoT is complicated and difficult to put together. But there's a number of stakeholders in there, whether it's the end customer, the enterprise that's selling it, whether it's the network provider, whether or the cloud system, the back end provider, or whatever. All of those have pieces that they all say they work in IoT and they all deliver IoT. But actually, therefore, where AI comes into that, there is going to be different if you ask each of those players. Now, obviously, we're one of those players in there. But I suppose if I was looking at where it comes in first, it clearly comes in first at the application layer, which was coming from your previous the previous question. And the reason is one of the issues is about repeatability and auditability around those elements. And at the moment, what a lot of the network elements need a repeatability and auditability for those elements. It's a bit like safety testing and those sorts of things, closed loop algorithms, etc. You need to make sure the loop is closed and is under control. And so the networking side, I think, is probably for at least the immediate year is still in machine learning control level of closed loop. So where does AI come into this, which is clearly being used and coming in? We see an increase in our number in customers that are using it on their application side, whether that's in the back end of the application for making better decisions or around the application itself, or actually on the device side as well, where trying to process large amounts of data on the device, and therefore remove the need to send all of that data straight up into the cloud for further processing, and therefore be able to make decisions on the device itself.
You mentioned network level, network layer. Do you see that as being distinct from the application layer? In other words, is there an untapped opportunity for AI to provide intelligence, insight from rich network layer data, which goes back to the first question of the MNOs, and if they could embrace a multi-operator environment where every device has a different network state depending on its deployment, is there an opportunity to provide network level artificial intelligence?
Yeah, I mean, I think
APIs, for example.
I think it will evolve through the normal processes, because the controls and the guardrails need to be put in place to make sure that all the stakeholders are happy to for that level of control. But I think you're clearly, if you look at a federation where you've got multiple players, multiple routes to be able to deliver connectivity to a device, the decision about which route to be being able to use is not a simple decision. It's based upon lots and lots of factors, quality of service, requirements of the device, location, availability of networks, etc. And this is all information that today is being processed by algorithms inside people like ourselves. But that to sort of take those guardrails off and pass it over to an AI agent is coming, but it's not necessarily there. But even when you do it, you still need to define the definition of success, as in what are you trying to achieve by this? Because not every IoT application has a different definition of success, because they're trying to achieve different things by their connectivity. A video streaming application is completely different to a metering application, for example, and what success looks like is different. And what that means is that those algorithms need to be controlled, and those guardrails need to be configurable via the APIs. And that kind of is where we are focusing our attention on, is making sure that those APIs to define the rules that the network is going to work within is the next step of that evolution, because then the customer the federation partners can define the rules, and it's that conjunction of rules that means that manages those devices. Because you've got millions of devices on network, you're not managing them individually. It has to be the machine has to be managed by the system.
This has come up actually on a previous podcast, IoT Leaders podcast, but we didn't actually position it with a AI wrapper, and it was the one that Amazon did, one of our most, I think it's either the number one listened to or the second number one listened to podcast. Obviously, Amazon talking about their key for business project, which I described as a small ambition to own every door in the world. But essentially the idea of automated entry to any door by any delivery company, by having secure access and the ability to get inside and have it recorded, and you as a consumer can see it's been done. So you don't have to wait in all day. And from their point of view, they increased their first-time percentage of Amazon Prime from 84% to 92%, which is worth billions of dollars. So we talked about that in a podcast, and if listeners want to know more about that, you can find that by searching through the list of podcasts. But one of the things that the main guy, the project owner, Vijay, said there was right towards the end of the podcast, he said, right now we're doing optimization of the connectivity down at the zip code level, but ultimately we want to do optimization of connectivity down at the device level. Because there are now, with an agnostic platform, in the way we described in question number one, a platform that's agnostic to the operator, you now have multiple paths to connectivity, cellular connectivity paths to every device. And if it's agnostic RAT, it's going to get multiple RAT types, so even more paths to every device. But as you pointed out at the beginning of your answer, it's not just, oh, do I have connectivity? I'm going to optimize it as the MVNO, and I'm going to choose the one where I have to pay the least because I've got a fixed price contract to my customer. So I'm doing least cost routing to the device. But now it's the network state information, like, what is the network like? What is the latency like? What's the signal strength like? A whole series of network parameters, which actually are ingredients in making the decision on the switching algorithm, as you call it. So as the number of right now, we're not making granular switching. The industry isn't making granular switching decisions based on rich network data at the device level. And what you're saying is that once you can have that network, all the devices on one network, in our case, it's one MPLS network from 16 operators and almost 800 roaming agreements for millions of devices. But once you've got the network data, then you've actually got the data that can be used in a machine learning or as training algorithms or whatever, training data to actually have AI decisions to, in my mind, achieve the Amazon vision of having long tail personalization of the connections, where they are dynamically choosing the best connection or the best network connection based on exactly what is happening right now with that device, which might be different to what's happening to that device in 2 hours' time.
Correct. And that leads to a point of also that one of our focuses is about getting consistency from our partner networks, so that data that's being interpreted and processed, no matter which partner you're using or where your device is in the world, has the same level of provenance, so that you can actually make those decisions on it. Because if you've got a weak link in that chain, then that becomes something that could drive a wrong decision.
So almost like a metadata abstraction of if we're going to make decisions based on 30 parameters, not 3 or 5, then you've got to be able to collect that data from everybody, which comes back to how you interconnect with those. It's got to be right in the foundations of your interconnect with the operator, because otherwise you're comparing apples and oranges and you don't know what it all means.
Correct, absolutely. So I mean, to bind you back to that the question, that's where we see that going, and that's really what we're focusing on from our point of view to meet the Amazon vision, etc. But equally, in the shorter term, I'll just pull us back slightly to the shorter term, we see increased use of AIoT really with on the customer side, either whether that's video processing on the device or in the router type devices, or even on the cloud. So that's really where those entry points are from that we're enabling our customers to do, and we can help that by again providing them those APIs and those data feeds for rich data that augments that. But really the evolution from our point of view is it coming across every part of the IoT chain, not just the application side.
So, which brings us in a nice neat circle right back to where we started from, because we talked about the need for the operators to not only embrace new platforms for, I'm going to use your analogy, dynamic pricing, but also to do land and expand selling, because simply doing connectivity is not enough. They want to climb the value stack if they've chosen that as a strategy. And one of the ways they can climb the value stack is if there was a way of getting this rich network level data to optimize their models and their value-added services that they offer to their customers.
Yep.
So that is probably going to be a very big subject that we'll go into a lot more detail in the future, but is a real use case already backed up by several podcasts that we've done already of people saying the more advanced users who are really deploying very large, vast global estates and have a lot of technical capabilities like Amazon and others, saying, I want to go down to this area because the value for my use case, in Amazon's case, the cost of not delivering a parcel is 100 times greater than the cost of providing connectivity to the device. The prize is so big to get your quality level up that they know they need to use analytics and advanced algorithms and what we would now call this AI, network level AI APIs in order to be able to do that. Because if they can get 84% to 92% on 50 billion packages a year, whatever it is they do, and I don't think that figure is too crazy, I think it's not too far off. The cost of that and the benefit to Amazon is huge, but the benefit for us as consumers is even bigger, knowing that we've got, you talk about trust and provenance, we just know that the service is going to be delivered in a way where AI will be taking care of a lot of the choices, providing you've got that rich network level data from all the different operators, which is why it has to be some form of, we would say, Star Alliance network infrastructure, where you can see all of the operators and get that data from all of them and interpret it in the same way it's sent.
Okay.
Yeah. So that's what we say. Let's draw an end to it there in terms of the predictions. I think this prediction podcast is different to the others, not just because you're on it this year, but because all the Mark Twain references, but because I think the predictions that last year it was all about the device. The theme was every prediction we were saying was everyone pointed back to the device. This year, what's interesting is that these are longer term predictions. It's not like something's going to miraculously happen in 2025, but the trends appear inevitable that over a longer period of time, these things are very likely to happen, which is exactly how you started 16, 17 years ago of predicting things and then seeing them play out over a long period of time. So you do have form in terms of being able to predict these, and we will see in the medium term, shall we say, how these things play out. But in the meantime, Ian, thanks very much for being my guest. Thanks for being the 50th podcast, second appearance. And thanks to our listeners and viewers. I hope you enjoyed this. The IoT predictions, the Eseye predictions report will be available on our website. And as I said at the beginning, it is, I think I'm right in saying it's the #1 downloaded piece of collateral, so I'm sure there'll be a lot of interest in it. So Ian, as CTO and founder of Eseye, thanks very much for being on the podcast.
Thank you, Nick.